For a function continuous in the interval a to b, I told you that if integral fx dx is, say, capital Fx plus c, and we defined a to be this as fb minus fa, right? Capital FB minus capital FA. And then I told you that, well, this number, capital FB minus capital FA, represents the area under the curve from x equal to a to x equal to b. This is what I've been telling you. This is what I've been telling you. But not even remotely have I volunteered to offer a formal version of why this is going to be the case. Capital Fx is an antiderivative, is a primitive of fx, small fx, and that fb minus fa giving us this area still lies in a black box, What I'm going to offer in the next few minutes is a formal version of why this is going to be true. Why capital FB minus capital FA represents the shaded area. Okay? And why is it that this area is like an antiderivative function? This area function is an antiderivative function. Has to be now formally understood about time. Now, say this is a function continuous in an interval a to b. Let me look at an interval x to x plus delta x, x to x plus delta x. Right? This length is f of x, right? This length is f of x, and this length is f of x plus delta x. Yes or no? This length is f of x plus delta x. Clear? Now, so there are, let's say, there is this P, Q, R, and S, and say this point is T, and this point is T. And say this point is M, this point is M. Right? Do you realize this area under the graph, area TRSP, that's the area under the curve, right? TRSP is bigger than this, is smaller than this area PQRS of this rectangle, is smaller than this area PQRS of this rectangle. Yes or no? Right? But is bigger than the area TMSP, but bigger than this area of the rectangle TMSP, right? Right? Yes or no? Let me call this required area, this area, as delta A. Delta A. Right? Delta A is like an additional area from x to x plus delta x, isn't it? Is an additional area under the curve from x to x plus delta x. That means the change in area. When x changes by an amount delta x, area changes by an amount delta a, which is the area under the curve. Yes or no? Right? Less than area of PQRS. Now, what's the area under PQRS? What's the area under PQRS? Hey, this length is f of x plus delta x, isn't it? This length is f of x plus delta x. This is f of x plus delta x into delta x. That's the area. F of x plus delta x into delta x, right? Right? And area of TMSP, the rectangle TMSP. TMSP is this rectangle. What's the area of this rectangle? This length is f of x into delta x. F of x into delta x. Delta A is the additional area under the curve from x to x plus delta x. That's the change in area. When x changes by an amount delta x, area changes by an amount delta A under the curve. Delta means change, A is the area. Change in area, right? A is the area under the curve up to x. A is the area under the curve up to x, and delta is the change in area from x to x plus delta x. Now, TMSP. What is TMSP? Delta x into fx, right? Yes or no? Now, let me divide by delta x throughout. Let me divide by delta x throughout. So, on dividing by delta x throughout, delta A by delta x less than f of x plus delta x and greater than f of x. Yes or no? Right? And now, let me take throughout limit as delta x tends to 0. Let me take throughout limit as delta x tends to 0. Yes or no? Sandwich theorem. What is the limit of this as delta x tends to 0? The limit of this as delta x tends to 0 is fx. Now, fx is continuous. So, limit of f of x plus delta x as delta x tends to 0 will be fx, because fx is continuous at x, isn't it? If a function is continuous at x, then limit of f of x plus h as h tends to 0 will be fx. That's going to continuity at x, right? That's going to continuity at x. So, owing to continuity at x, this is going to be, this limit is also going to be fx. Yes or no? How about it? That means, now look at sandwich theorem. Sandwich theorem, right? Limit of delta a by delta x as delta x tends to 0. This function, lower bound function, tends to fx. Upper bound function also tends to fx. Then from sandwich theorem considerations, this will also tend to fx. That means this limit must be fx. This limit must therefore be fx. So, limit delta a by delta x as delta x tends to 0 is fx. Yes or no? Where delta a is what? The additional area from x to x plus delta x. A is the area up to x. A is the area up to x. Delta is the additional area from x to x plus delta x. How about it? Right? Good. Now, what is limit delta a by delta x as delta x tends to 0? dA dx, isn't it? That by definition is dA dx. Derivative of a with respect to x, right? That's going to be dA dx. where A will be a function of X. A is the area up to X. A is the area up to X, right? That's equal to Fx. Yes or no? dA then is going to be Fx dx. That's going to be the area up to X. That's going to be the area up to X, right? If I integrate both sides, integral Fx dx, let's say, is some capital Fx plus C. Integral dA will be A. That means area up to X. This will be area up to X is going to be f of x plus C. C will depend on where X is. Now, for example, if I take X equal to A, what's the area up to A? 0. X equal to A, the area will be 0. That means if I plug in X equal to A here, this number will turn out to be 0. Yes or no? So, f of A plus C, which is the area up to X equal to A, must be 0. Right? If I plug in X equal to B, then it will give me the total area under the curve. Yes or no? Right? If I plug in X equal to B, it will give me the total area under the curve. So, f of B plus C, that must be the total area, let's say A1 under the curve. That must be total area A1 under the curve. Now, if I subtract FB minus FA. Now, if I subtract FB minus FA, I get A1, the area under the curve. Yes or no? Is A1 under the curve. Where what is Fx? Fx is the primitive of Fx, small fx. Yes or no? This is the formal proof for y integral, right? Y integral Fx dx A to B, which is Fb minus Fa, represents the area under the curve. Sounds good?